Okay, so today's lecture is about Thomas Kuhn. It's the third lecture for this week. It's the final lecture for this week, and it's another philosopher of science attempt to answer the question, what is science? We've already seen this answer with Bacon and Popper. Popper was largely responding to Bacon and the inductivist model of science. Popper tried to overcome the problems with induction by signaling out a demarcation criterion, and he said that the mark of what makes something science is, is that it can be falsified. And so, what makes something a scientific claim is that it can be falsified. It's capable of being tested and falsified, and therefore that's what made something a scientific claim. And today we have another philosopher of science, although his philosophy of science is different than Popper or Bacon, because he is looking more at science as a whole rather than at individual scientists. And for Kuhn, in answer to the question of what science is, if science has some essential nature, if we can figure out what that nature is, we cannot disentangle that question from its history. We must look at the history of science as a whole to figure out an answer to the question what science is. So the two cannot be disentangled. In particular, Kuhn is interested in the question, how does science make progress? How are we able to tell when there has been progress made in science, when it is getting better, for example, or headed in a different direction? If we look at its history as a whole, can we identify any patterns or structures that emerge as we look at it that might give us some clues about when science is changing fundamentally? So that is Kuhn's real interest, is looking at the history of science to try to figure out whether there are any structures or patterns that will reveal to us something essential about the structure of scientific change. And so that's how Kuhn is coming at this question of what science is. Popper was also interested in the history of science, but Kuhn is focused more on the history of science as a whole, as a kind of cumulative, progressive enterprise over its entire history, beginning with the modern period of science and then up to the present. And so that's what's going on with Kuhn. We're less interested in individual scientists and their experiments and more on the patterns and structures of science as they emerge throughout the history of science. And so this claim that we cannot disentangle the history of science from the nature of science, that somehow asking the question, what is the nature of science, means we also have to ask about its history. There's a worry there. And there's a worry there about the truth of science then. Because if all we have are a bunch of different historical periods, so to speak, the worry is that we're going to be left with something like relativism, which is to say that certain scientific claims are true for a specific historical time period, but they stop being true, in a different time period, and therefore scientific truth, becomes relativized, which is to say it becomes dependent on and relative to a specific time period. And that is the worry for someone who would try to identify something as the scientific method, like Bacon, that there is this thing called the scientific method that is ahistorical, that transcends specific time periods in philosophy, or within science, and that we have this thing called the scientific method, and we can apply it across all time periods. And so that is an attempt to avoid the kind of relativism that would creep in with an approach like Kuhn's that demands we acknowledge the history of science. Whereas the sort of objection to Kuhn is to say that we can't relativize scientific truth to specific historical time periods because then we don't have anything like scientific truth. We just have a bunch of scientific truths um, for specific, but once the time period is over, the thing stops being true. Um, and but Kuhn's response to that is simply that there is no evidence in the history of science that there is this one unchanging, ahistorical, atemporal scientific method. That is not how the history of science has unfolded. That there's not this method of science that is true once and for all time, and that scientists simply just take that method in any given time period and use it to discover the truths of science. Kuhn wants to say that's not how we can account for progress in science. Oftentimes, science doesn't make straightforward linear progress. Science sometimes has to go backwards before it goes forwards. Maybe it takes 2 steps back before it takes 1 step forward. And so progress in science does not need to be imagined as simply a straightforward linear model. Progress can be imagined as needing to go back sometimes. And then in order to take a step forward, we need to go back. There's nothing contradictory about thinking of that as progress in science. But if we take the model of Bacon and the inductive model of science, then it only allows us to conceive of progress as simply straightforward linear progress, where the image is simply, well, here's scientist A. Scientist A makes their discovery, collects facts, discovers new things. Scientist B comes along, refutes scientist A with new facts, new discoveries, and new things. Scientist C comes along, refutes them, and you just keep sort of marching forward as a slow, steady progression. Whereas often science fails miserably, but that is also part of its progress. There's nothing contradictory about suggesting that science has to go backwards before it can go forwards. We can still consider that progress. And so that is why Kuhn is so insistent upon looking at the history of science as the necessary accompanying question to what is the nature of science. We must ask about what the history of science is if we are going to ask what the nature of science is. The two questions cannot be disentangled. Now, Kuhn also has a response to the worry about relativism, is that we actually can make some claims about the truth of the history of science. And this is going to be where his positive philosophy of science comes in. Kuhn is going to say that we can extrapolate some structural trends, which is to say things that are true about the history of science as a whole, not about particular time periods, but about the history of science as a whole, and that these trends continue to emerge throughout the history of science, and that it's this positive vision of his philosophy of science that I want to talk about now. So Kuhn has a very well-known term known as a paradigm. And a paradigm is something that it's language you hear all the time. You hear the language of paradigm shift. And that often comes from Kuhn, but you hear it in all kinds of contexts, paradigm shift. And that language comes from Kuhn. But before we talk about a paradigm shift, that's more associated with something that comes later. What is a paradigm? Kuhn argues that science operates within paradigms, that it operates within a given paradigm, and that a paradigm is a framework for understanding the world, and that in order to even talk about the world, you have to have a common language and a common vocabulary that all scientists share together, and that communication would not even be possible without this shared language and this shared vocabulary, and that is what's going on. So when they're during particular time periods in science, they operate within these paradigms. But there are also periods in science that exist before the paradigm, where there is a state of confusion and a state of chaos, so to speak, where there is no agreed upon vocabulary. Scientists are kind of groping in the dark, so to speak, to try and figure out what their field is going to look like, what their field is going to be. There's no common vocabulary and no agreed upon set of rules and methods for doing science. So pre-paradigm science is not science at all, because it's simply the search for a method. But what Kuhn argues is that if we look at the history of science, we can actually locate specific discoveries, major scientific breakthroughs that break us out of pre-paradigm science and allow for a paradigm to emerge. But for a paradigm to emerge, what's required is a specific breakthrough or discovery. And this specific breakthrough or discovery is what gives the specific vocabulary and language for scientists to use. It allows them to communicate with each other. And Kuhn argues you can see this all the time with the emergence of a new scientific field. What we see then is we see the emergence of things like journals that emerge, conferences, maybe departments at universities are created. And he thinks all of this is evidence of a new paradigm that has emerged as a result of specific breakthrough discovery. And that if you don't subscribe to those rules, then you won't find yourself being part of this scientific community. Now, once a paradigm is established, what it means to do science within that paradigm, Kuhn argues it's called normal science. The work itself going on within the paradigm, the shared paradigm, is called normal science. And Kuhn further describes the work of normal science, and I may use that interchangeably with paradigm science. Paradigm science and normal science mean the same thing. The work going on within normal science is what Kuhn calls puzzle solving. Now, why does he call it puzzle solving? Well, the reason is that the paradigm gives you the vocabulary. It gives you a method to do science, but it doesn't tell you how to do it. There still has to, the details and the experiments and the hypotheses and the testing, that all still has to be done. It's not once we have the breakthrough, then it's done. There's still lots, science has to be done. The work has to be done by the scientists. But we have the method. And so the method is the rules of the game, but it doesn't specify that just because you know the rules that you will be good at the game. And so, he does give the example of puzzle solving like Sudoku. Simply because you know the rules of Sudoku, if you sit down to do a puzzle one day, you may not be able to do it. You may just be terrible at it. So simply knowing the method and knowing the rules does not mean that you are now a scientist. You have to actually be able to apply the rules, apply the methods to specific problems, do experiments. And that is when, that's the work. That's puzzle solving. That's the actual work. The paradigm gives us the method, but the method must be applied. That's the argument. Now, normal science, paradigm science, can go on for quite a long time. It can go on for potentially decades, centuries, right? But what may happen is that something arises in the work of normal science, that the method cannot account for. No matter how hard, no matter how hard scientists try to solve this problem that has emerged, it cannot be accounted for by the rules of normal science. The method that was discovered for the original paradigm cannot solve this problem, and Kuhn calls this an anomaly. And so it can't be solved. And in fact, at this point, something else has emerged to challenge the something has emerged that is going to challenge the paradigm. And this is a period of crisis science where you have the anomaly. The anomaly is present, but it cannot be accounted for. And now we have a rival competing hypothesis that is attempting to explain the phenomenon. And so now we have crisis science, where there is no unified theory. Now, eventually, the anomaly is accounted for by the rival theory, and this is called revolutionary science, when the methods of the old paradigm are displaced by the methods of the new science. And now we have revolutionary science, which totally displaces the old set of assumptions. You have an entirely new set of assumptions. You have an entirely new vocabulary and a new method for solving these problems. The anomaly fundamentally got rid of the old paradigm. The new method solved the anomaly, and now we have revolutionary science. That is Kuhn's argument. And a really interesting claim is that Kuhn argues that between the new paradigm and the old paradigm, he argues that there is a fundamental incommensurability, that the new paradigm and the old paradigm cannot talk to each other. There is no communication taking place. In fact, the vocabulary is so fundamentally different and so fundamentally altered that there can be no communication taking place. And he calls this incommensurability. And this is an interesting claim. And this claim is illustrated specifically on page 'Well, I don't have it in front of me, but actually, if you look up the image of a duck rabbit, if you Google image the duck rabbit, look that up. The image of the duck rabbit is supposed to illustrate this incommensurability between old and new paradigms. That you're looking at the duck, and you see the duck. But yet, once you realize that the duck can also be a rabbit, it's no longer possible to only see it as a duck. You now have to see it as both. You can never look at the world in terms of the duck again. The duck is also a duck and a rabbit now. And so the world takes on new meaning. There has been a paradigm shift, so to speak, in which it is no longer possible to see the world in only the terms of the old paradigm. It's simply impossible once a new way of seeing the world emerges. And so now it's only possible to see the world in these terms. You can no longer see it only according to the old terms. So once you tilt your head or you tilt the picture and see that the thing can be both a duck and a rabbit, it can no longer just be a duck, and it can no longer just be a rabbit. It is now a duck rabbit. It is both. And so that image is supposed to illustrate the notion of a paradigm shift, that the paradigm shift is so fundamental to like the way that you see the world. It's like putting on glasses and taking off glasses. This is a paradigm shift. Once I put them on, it's no longer possible for me to just see the world. Now the world is totally different, right? So that's a paradigm shift. And an example of this that I often use in class, because I think students are skeptical of Kuhn's claim about this incommensurability, is I often think about mental health. And I think about the paradigm shift that occurred when I often think about the paradigm shift that occurs in mental health with the notion of a chemical imbalance. That now we actually, in the 20th century, and psychiatry is a fairly new field, but that now mental health can actually be explained according to the biochemistry of the brain. That we can now explain mental health in biological terms, and that it can be treated. And so, prior to the advent of something like modern psychiatry and the use of something like antidepressants to treat mental health, it was thought that those who had mental illness, that there was something wrong with them, fundamentally, that they couldn't be treated, and that they were insane and that they needed to be locked up. And now we have somebody, with the discovery of the chemical imbalance in the brain, we were able to treat mental health. And so you think about the two individuals, somebody who thinks that there's something wrong with somebody with mental health and somebody who just thinks, um, no, they can be treated. You think about those two trying to have a conversation. That's often that's one of the best examples of it. There's lots of paradigm shifts, but for me, that's the one that always comes to mind, and I think it makes a lot of sense. That's all I have for Thomas Kuhn, and that's the final lecture for this week.